Now that you've understood what a data warehouse is and why it is needed, let us move on to a discussion of some of its most important concepts. This lesson has an overview introducing these concepts. We will look into these concepts in more detail in upcoming lessons. Let us discuss star schema in the next screen. Data warehouses have specialized structures that enable high-performance queries while still being implemented within a normal database. This specialized structure is called a star schema. This structure is what defines a unit of query in a data warehouse. The star schema is a conceptual model. That is, there is actually no separate entity or component that provides this structure. It is implemented via standard tables and relationships within the database. However, while these tables are normal, there are two distinct types of tables and their data that is defined in data warehousing concepts that determine what kind of data goes where. The two types of tables are called dimension tables and fact tables, or more colloquially, dimensions and facts. We shall see what these tables hold a little later in this lesson. For now, the star schema defines a fact table surrounded by multiple dimension tables to form the central core and the points of the star respectively. This star basically represents a data mart, the unit of data against which you will run a query. You can define a star with 2, 3, 4, or more points, as is required in your organization. Not only that, each data warehouse can contain many such stars or marts. Each mart defines a different unit of data, many a time using dimensions and facts from other marts as well. Let us discuss the uses of star schema in the next screen. The star schema was shown as a conceptual diagram on the previous screen. You can see an example of a star schema defined in the database as tables in the present screen. The middle fact table is surrounded by a number of dimension tables as points of the star. The star schema modifies highly normalized tables in OLTP to simple, denormalized structures in data warehouse. It is optimized for quick data query access. If you note in the diagram, none of the dimension tables are related to each other directly. Instead, they all only use a join back to the fact table only. A star join query optimizer component in SQL Server 2012 further optimizes this structure when it detects that the tables are arranged in a star schema pattern. The star schema is a standardized, well-recognized structure. It is not a Microsoft invention or used only in SQL Server. Almost all BI systems understand and use this schema and can be used to interoperate between different tools, including SQL Server and other third-party ones. Star schema is interoperable between SQL Server and other tools. Many different vendors and their tools and decision support systems work with star schemas seamlessly. When using BI, getting your data into a data warehouse and star schemas is an important step. This schema is capable of storing and processing massive amounts of data very easily. We shall soon see why this is so. Let us focus on dimensions in the next screen. As you just learnt, the star schema has two types of tables in its structure. Now, let us discuss one of the types, that is, dimension tables. Dimensions, to reiterate, are the tables that make up the points of the star in the schema. Dimensions are the pieces data that you wish to measure something against. For instance, you might want to measure the sale amount against each product. In this case, the product is a dimension. If you wish to measure the sale amount against some other value, such as against an employee of the company, then the dimension is the employee record. A data mart can define a number of such dimensions at the same time. Your query determines which dimension is used for the data, and you can use as many as you want simultaneously. Each dimension table consists of a number of columns, which are called attributes in the context of data warehouses. These attributes are actually the ones that are used in a query to display a value. For instance, a product's dimension would have different attributes, such as name, category, color, and model. An employee dimension could have attributes such as name, gender, age, department, and more. When you perform a query in a star schema, you use any combination of these attributes from different dimensions. For instance, extending the example given earlier, you could measure the sale amount against each product color versus the gender of the employee who sold it, if you wish. The meaning of the results is something you can use to analyze and use. Dimension tables usually do not have large number of rows. This is because these are used similarly to a master table in a normal database. Dimension tables store all the unique value combinations of that unit of data, such as rows for each product, along with the attributes such as category, color, and model. Technically, there is no limit to the number of records you want in a dimension table as long as the source data does have those. Data warehouse conventions state that all dimension table names are prefixed with the word dim. So a dimension for products would be named dim product, and one for customers would be dim customer. It is strongly recommended that you follow the same convention when creating a warehouse yourself. This is because many tools auto-detect dimensions tables by looking for their prefix. Let us focus on facts in the next screen. The other type of table that is used within a star schema is the fact table. Facts are the central core of the star in the conceptual diagram and contains the actual values that are to be analyzed against attributes of dimensions. For instance, in the example we talked about in the previous screen of measuring sales amount against the attributes of color versus gender, the fact here would be the sales amount. Any data that can be measured is part of a fact table. This is why most of such values in a fact table are numeric in nature. These values are easily measurable and aggregated across multiple dimensions. Fact tables also contain other columns, such as keys and other information. We'll go more into detail of this sort of table in a lesson dedicated to fact tables later in this course. As with dimension tables, the convention for fact tables is that they are prefixed with fact for tools to recognize and use them appropriately. Fact tables are also capable of storing massive amounts of data for analysis. Let us focus on keys in the next screen. Keys are an important part of a star schema. They are what connect dimension tables to fact tables. Both these tables contain primary and foreign keys. In fact, fact tables most contains foreign keys point to different dimension tables along with the measures they offer. Each record in a fact table is linked with all the different dimension tables using foreign keys. Data warehouses introduce a new type of key as a concept. These are called surrogate keys and are used to identify records from different data sources. For instance, consider a case where a particular data warehouse collates data from different sources, such as databases, ERP, and CRM systems. If the same primary key value is used by different records in different sources, it would be difficult not just to collate them in the data warehouse, but also to identify the source from where each was obtained. This is where the surrogate key comes in. The data warehouse basically uses a newly created primary key for each record. However, it also stores the primary key as a column in the same row as an alternate or a surrogate. Using this allows you to identify the original record in the source data quite easily. Do note that in some implementations and documentations, the surrogate key is referred as an alternate key. These both are the same concept and work exactly as described. Let us look into a few other schemas in the next screen. We've discussed the most commonly used structure in data warehouses, the star schema, till now. However, there are a few other but lesser used schemas that are available as well. These schemas are used in special cases in data warehousing. The first one is called the Snowflake Schema. This is actually an extension of dimension tables. It allows dimension data to have hierarchies, which enable scenarios such as drill downs. The screenshot on the screen shows a sample snowflake of the product dimension. You can see that the dimension has a hierarchy that goes up to a subcategory dimension and then to a category dimension. This enables scenarios such as being able to drill up or down between product, subcategory, and category against a measure. There is a performance hit due to the normalization that is added here. Do note that SQL Server has an alternate concept by which you can still get the same drill up or down capabilities while keeping a single dimension table and doing away with snowflake dimensions. The other schema is called a fact constellation schema. In this, rather than a single star, the schema contains multiple star schemas linked to each other, basically forming a constellation. Facts and dimension tables are shared with each other and enables additional aggregation scenarios that are not available when using single star schema structures. However, fact constellation structures are extremely complex to plan, set up, and implement, and examples of these are few and far between. In this first demo of this course, you will explore a RDBMS structure and then see the data within it represented within a data warehouse.